Tell my boss whatever they need to know, right? And then go to lunch. Okay, good. All right, so everything's there. Are there any questions on that? So in an open switch, you need to make sure that you have a voltage arrow on the switch. Okay, if they ask you a circuit question on the AP exam, for sure, if there is a switch on, for sure they're going to want to see a voltage arrow. They'll ask you some kind of trick question to see if you really understand that the voltage rise is across the switch. Got it? Okay, good. So any questions, any other questions on that? Okay, now, since it's open, that's great, but now we have to analyze it closed. So we got to do a whole new circuit. So I have to rewrite the entire circuit. But before I do that, I need to know what I can bring over from here to my new circuit. Now, resistors don't change. So resistors remain the same. So I can bring every resistor over into my new drawing, the value of the resistor. Okay, I can bring over the value of the resistor. The other thing that doesn't change is a battery. Because doesn't the battery voltage, isn't that what the purpose of the battery is to maintain a constant potential difference? So if it's 18 volts when the switch is open, when I close the switch, it's still going to be 18 volts. So the V battery remains the same. V bat remains the same. Everything else goes away. You have to reanalyze the voltages and currents in each of the resistors. Okay, and the current coming out of the battery. Okay, so the only thing I can carry over is V bat, this 18 volts. Everything else needs to go. So go ahead and redraw your circuit. I'll do mine teacher stuff. Okay, but what we're going to do now is we're going to have a closed switch. So this thing here now acts as a wire. It acts as a wire. Okay, so a closed switch acts as a wire. And all I do is ignore it. When I have a closed switch, I just ignore it and analyze my circuit like I know how. T goes away, and anything else goes away. So all I'm left with is this now. Okay? But now I don't, because I have a wire, there's no potential drop across the switch. It acts like a wire. Okay, so everybody got it written down? Close to it? Okay, good. So now what I have to do is I have my voltage and current arrows done. Okay? I put in my label is given, right? This no longer is true because it's a current, so I have to get rid of it. And a voltage, add a resistor. So I get rid of everything about a resistor. The only thing I keep is the battery voltage, and so I brought that over as a given. Now I have to calculate RT. Okay? This is not an easy circuit. Okay, so what I have to do is identify the type of circuit it is. So what kind of circuit is this? Parallel circuit. So that means that when I pull out the 4 ohm resistor right here, there's an alternate path for the current to flow. Is that correct? Is that what you're telling me? No. So if I pull this resistor out, it doesn't shut down the circuit. No. It does? Is that the definition of a series circuit? Isn't that the definition of a series? So it's not parallel. Is it? That must mean that it is series, right? So that if I pull out this 2 ohm resistor, there's no way for the circuit to run. Wait, there is. So as Connor said, it's a combo circuit, okay? It's a parallel circuit, okay? Combo, all right? Combination, series, and parallel. It has aspects of both, right? For instance, this 2 ohm resistor is in series with that 4 ohm resistor. But those two things are in parallel with the 2 ohm resistor. This 4 ohm resistor is in series with the entire rest of the circuit. Okay, make sense? Okay? So, what we have to do in order to calculate the total resistance, what we do is we piecemeal, we slowly simplify the circuit until we get it back to 1 resistor. And I'll show you how we do that. So, the first thing I'm going to do is whenever we're simplifying or drawing equivalent circuits, we generally, not always, go far from the battery and work in that region. So if I go over here, right, I'm going to work in this region. And I already know I've identified these 2 resistors as in series. So what I'm going to do is I'm going to combine them into 1 resistor. So I redraw my circuit, keeping everything the same except for those 2 resistors. So here's the 4 ohm resistor. Here's the 2 ohm resistor. Okay? And now what I've done is I want to replace these 2 resistors with 1 resistor that has a resistance of 2 plus 4 ohms equals 6 ohms. So you see how that circuit looks simpler. I've made it simpler in 1 step. Okay. So now I've had this simplified a lot, so I'm still working a ways from the battery, okay? And so what do I notice about these 2 resistors? They are in parallel. So what I want to do is I want to focus on this thing here and make it 1 resistor. So I'm going to redraw my circuit. Here's my 4 ohm resistor that's untouched, right? I didn't touch it there, or there. And now what I'm doing is I'm combining these 2 resistors into a single resistor right here. And so this is going to be 2 to the negative 1 plus 6 to the negative 1 to the negative 1, which is what? I need you to get your calculators out because it's very difficult for us to make a circuit that works with nice numbers when it's open and then works with nice numbers when it's closed. It's very hard to make that. So these things get a little tedious on one side or the other when we're working these types of problems with switches, okay? So what's that come out to be? 1.5, okay? So we end up with 1.5 ohms, okay? So now I'm left with what kind of simple circuit? Series. So I'm left with a series circuit that has 4 plus 1.5 ohms, which is equal to 5.5 ohms equals RT. Okay? Everybody okay with that? So 5.5 ohms is RT. So now I have my equivalent circuits. I now have circuits, equivalent circuits. And everything, I've followed the procedure, so now I can start analyzing using V equals IR, KVL, or KCL. Do I know 2 of 3 things anywhere for my circuit? I do, at the battery, don't I? I know that the voltage of the battery, and I know the total resistance that the battery sees, so I can calculate the current that comes out of the battery, right? I can say V bat is equal to I times RT, right? The battery. And so I can say 18 volts is equal to I times 5.5 ohms. So what's my current at the battery? 3.27 amps. Okay, so now I can write 3.27 amps. Okay, good. So I calculated 3.27 amps. whatever I calculate, always use that as kind of a launching point to the next thing. So if I calculate an amp, think amps, where can I use that to help me? If I calculate a voltage, where can I use that to help me? Okay, got it? So we just calculated an amp. Where can I use that newfound knowledge to help me in the rest of the circuit? I know that 3.27 amps goes out the top. That doesn't help me too much because it splits. But I do know that 3.27 amps go in the bottom as well, and I got a lone resistor on this leg. So what's the current there? 3.27, right? So I get 3.27 amps going towards the battery through that resistor. And now I ask, do I have what? 2 of 3, so I can calculate what is the voltage there. Isn't it 13.1, I think? 13.1. 13.1 volts. Awesome. Okay, so now I just got done calculating a voltage. Think voltage. How will that help me get another part of the circuit? Well, let's think KVL, right? The loop rule. Since I just calculated a voltage, do I know from A to B? 18 volts. So if I go A to B another way, then I should be able to get 18 volts. If I go 13.1 and then up some amount, it should equal 18 volts. So what's 18 minus 3.27? 4.9? 4.9 volts. I got that by KVL. I got it by KVL. Now, again, I know 2 of 3 things. 4.9 divided by 2 is 2.45 volts, right? Or amps. So I get 2.45 amps going through that leg. Okay. I just calculated an amp. What can I use? Can I use that to help me with anything?
Yes.
I know that amps are used in KCL, so is there a junction that what I just calculated will help me determine something else in the circuit? And indeed it will. The same reasoning, I can do it at C or I can do it at D. I'm going to do it at D because there's more room. But I could just as easily do this at C. Okay? I know that coming out of the battery, I have 3.27 amps. I know just from this calculation that this direction, the current, is 2.45 amps. So that means that my current going this way has to be what? Based on KCL. 0.82, right? 0.82 amps. Okay, great. So now I know what? That 0.82 amps goes into what kind of circuit? A series circuit, and we know that the same current flows through each of the resistors in a series circuit. Does that make sense? So now I know this is 0.82 amps, and I know this is 0.82 amps. And so now I know 2 of 3 things. Now, I'm not going to get on you whether you do one or the other, but just follow me on this so that I can make the story straight for everybody, okay? I'm going to pick this start here. So 4 times 0.82 is how many volts? 3.2. Exactly, right? 3.28 volts. Okay, I just calculated a voltage, and so what can I use to help me get something else? KVL, right? Like I said, this works a lot. It doesn't work every time, but if you just calculate something, think, if I calculate a voltage, think KVL, it's going to help me on the next step. Or if I just calculate a current, think KCL. Okay, so I just calculated a voltage, so let's look at KVL. So if I go from C to D, I have to go up 4.9 volts. If I go C to D this way, I go up 3.28. What gets me to 4.9? 1.62, doesn't it? Right? So by